Black holes, the strangest things in the universe. They seem to alter reality itself, creating complex but interesting ideas in physics. But what exactly is a black hole? How is one formed? And what makes them so weird? Technically, to form a black hole, we need to get a certain amount of mass in a small enough region. To get exact values, we have this equation, where you plug in a value for mass and get the value of the radius of the region in which we have to compactify this mass to form a black hole. To give you an idea of how dense this needs to be, if you had to make a black hole of the Earth itself, it would be only 1.7 centimeters in diameter. That's it. All that mass in a region smaller than a coin. Usually, such events only happen on astronomical scales, so the secret to making stellar black holes lies in the formation of neutron stars. Any ordinary star is fueled by the energy provided to it by nuclear fusion happening inside. Due to this fusion, layers of heavier and heavier elements are formed inside, all the way till iron. The nuclear fusion making iron doesn't release any energy, thus, the star collapses onto itself under the influence of its own gravity. It bursts into a supernova, resulting in the formation of a neutron star. If you looked at this on a quantum level, as all the mass rushes inwards, the electrons in the atom combine with the protons, forming a nucleus comprised of neutrons. So now we have an extremely dense sphere of neutrons. As you can see, this isn't a black hole, and I just tricked you into learning a bit more about neutron stars. Thank you for watching. Just kidding. We want to make a black hole. Let's bring in a quantum concept here called the Pauli exclusion principle, which states that no two fermions can occupy the same state at the same time. What this means is that suppose two fermions have the same momentum, they must have different positions, and vice versa. To visualize this, let's think in not three-dimensional space, neither in four-dimensional space-time, but in six-dimensional quantum phase space. Bear with me for a moment. To make this easier, here the 6 dimensions are split in two, 3 dimensions for space and 3 dimensions for momentum. In the case of a neutron star, all possible states are occupied by the neutrons, as it is so dense. And here, another quantum phenomena comes in, the Heisenberg uncertainty principle. As the positions of the neutrons is so well defined, the uncertainty in the momentum of the particles increases by a lot. In the phase space visual, the momentum space increases, and the denser the neutron star gets, the more it will increase. So now, if the neutron star had more mass, it would not be larger. Its momentum space would increase, actually making it smaller in position space. If you kept on adding more mass somehow, or if it had the required mass from the beginning, there will be a point where the neutron star collapses under its Schwarzschild radius, making it a black hole. Cool, so we finally have a black hole. Now let's explore it. Firstly, what exactly is a black hole? To answer that, let's see what would happen to someone falling inside one. Here we have two astronauts. Let's call them Alice and Bob. Alice is at a safe distance from the black hole, while Bob is sent spinning inside. As Bob approaches the black hole, due to time dilation, Alice sees him spin slower and slower. Don't get this confused with Bob's acceleration. He's still falling towards the black hole with increasing acceleration. Bob also appears to get redder and dimmer as the light gets redshifted due to the gravity of the black hole. When Bob reaches the event horizon, something really weird happens. Alice sees him frozen in time due to infinite time dilation. Alice can wait for how much ever time she wants, but from her perspective, Bob is just frozen there. That sounds absurd. Bob isn't actually stuck there. At one point, he did fall inside. So what is going on? Are the two people experiencing different realities? Not really. This can actually be explained with a Penrose diagram, which I'll not get into right now. So, to now answer, what is a black hole? A black hole isn't really a thing, which you might have guessed by now. Neither is it a region in space-time. I'll tell you why. It's a common fact that nothing can escape a black hole, not even something traveling at the cosmic speed limit, for example, light. This is because inside a black hole, space and time switch roles. So it's not really space-time, it's time-space. So, a black hole is a set of all such events like the one I just showed you, and it just ends up looking like a sphere in four-dimensional space-time. Pretty crazy, right? Well then, why do we treat them as objects? That's because outside the event horizon, they do act like objects. If the Earth did become a black hole, the Moon would still be orbiting it. It won't just suck it in, which is a common misconception. I hope these ideas interested you, but this is just the tip of the iceberg. There is a lot more mind-blowing stuff out there, like how exactly space and time switch roles in a black hole, singularities with infinite curvature, the holographic principle, and much more. These are topics for upcoming videos. Thank you for watching.